On September 4, 1980, Salvage Superintendent Ken Olson ordered his primary Caterpillar D8K straight into the smoking gray wasteland of the Mount St Helens blast zone. The planetary power shift transmission was already running at 158 degrees Fahrenheit. The mountain was still settling. Olson adjusted his industrial respirator as the heavy D342T diesel engine clawed for traction on a 40% grade buried under 3 feet of pure tephra dust. Unit 8342 was completely on its own out here. How much difference could one machine make against a ruined forest? The volcanic dust wasn't normal dirt. It was airborne abrasive glass that ate through hydraulic cylinder seals like coarse sandpaper, drops of premium fluid weeping onto the gray powder. Every blade stroke brought a grinding crunch through the steel floorboards. I know you can hear that sound ringing in your ears. Olson dropped the massive semi-U blade, but the 77,000-pound bulldozer hit something solid, hidden beneath the powder. Strange groans echoed from the torque converter as tracks spun fruitlessly. Was it a buried old-growth stump or solid volcanic bedrock? This wasn't just Olson's personal battle. By mid-September, Weyerhaeuser had assembled 65 individual Caterpillar D8Ks along this sector to execute the largest salvage logging operation in history. The company needed millions of cubic feet of timber moved before winter rains turned the ash into concrete mud. The contractor chose the D8K over lighter units for its heavy-duty D342T engine and 70,000-pound operating weight. Older D8H models lacked the oil-cooled steering clutches that this project demanded to survive continuous high-load maneuvering in the volcanic dust. Every hour on the job meant clearing thousands of massive old-growth trunks thrown down like matchsticks. Operators didn't have time to use standard skidding techniques. They utilized raw drawbar pull, pushing 5 giant logs at a time to maximize their speed. The output of these 65 crawler bulldozers kept 3 major regional sawmills running 24 hours a day. If the D8Ks lost their fight with abrasive dust, the local timber economy faced immediate collapse. 2 million cubic feet of timber per day was the baseline quota. Using smaller machinery or standard rubber-tired log skidders would have doubled the extraction timeline. Sharp volcanic rock splinters punctured heavy rubber carcass tires within minutes, turning operations into an expensive logistical nightmare. Only a heavy steel undercarriage had a chance out here. Forest Service engineer Raymond Davis published a formal memo claiming no conventional bulldozer undercarriage could survive 50 hours in this ash without losing track tension entirely. He recommended waiting 2 years for rains. Ken Olson read the memo, threw it away, and started his engine. Every morning at 5 a.m., the maintenance crew conducted a mandatory undercarriage inspection on Unit 8342. They used heavy steel scrapers to dig out the compacted volcanic cement, solidifying between the track rollers overnight. This vital ritual absolutely could not be ignored. By the end of week 3, the warning lights for engine air restriction were coming on every 20 minutes. Extreme glass dust bypass was destroying the paper elements of primary air cleaners, threatening the high-value D342T cylinder blocks. The mechanics had to improvise a solution fast. Before we get into the specifics, if this is the kind of content you've been looking for, consider subscribing. Everything on this channel is built around real machines, real operators, and real jobs. No manufacturer talking points. No content written by someone who has never been on a job site. If that matters to you, the subscribe button is how you tell us. And leave a comment. Have you ever run a heavy crawler bulldozer in high abrasive ground conditions like volcanic ash or granite dust? Now, back to the St. Helens salvage. To save the cylinders, field mechanic Ed Vance clamped oil-soaked nylon mesh over the intake stacks. It looked ridiculous, but it trapped 80% of the glass shards before they reached the primary filters. Do you think that was a real solution? Production deadlines loomed as Weyerhaeuser pushed for 70 million cubic feet daily. Olson ran Unit 8342 for 12 hours straight, without shutting down the heavy diesel. The D342T block simply had to endure. The abrasive dust began grinding down the track bushings. The undercarriage gauge was slipping, creating extreme metal-on-metal friction that heated the steel links to blistering temperatures. Every turn was a mechanical gamble, and the risk multiplied with every passing minute. Late September brought the first Pacific Northwest autumn drizzle. The water didn't wash away the ash as expected. Instead, it mixed with the glass dust, creating a thick, acidic paste that packed the final drive solid. The mechanical evolution of bulldozers and history's most punishing projects live in the membership section. Join for full access to 20-minute deep dives built for people like you. Now, back to St. Helens. Olson faced a 60% downhill grade with 66,000 pounds of timber trailing behind his winch. The wet ash made traction incredibly difficult. If his steering clutches glazed now, the D8K would become a runaway sled. This is not how you run a bulldozer according to the factory manual. You never slip steering clutches while heavy logging on mud. Olson knew the manual, but he chose survival instead, and took the risk. At 2 p.m., a sharp metallic snap echoed from Unit 8342's right final drive. The planetary gears had swallowed a wedge of solid silica. The tracks locked up instantly, stranding Olson on the slope. Ed Vance arrived with a service truck and a portable boom crane. They had to pull the final drive housing right there on the muddy mountain face, while the volcano vented steam 3 miles away. The replacement gears weighed 400 pounds. Vance and Olson hoisted them by hand into the open housing using grease-slicked cables. The corporate quota demanded this iron back in the dirt, and time was running out. The D342T roared back to life on the first turn of the starter. Olson slammed the power shift into first speed forward, the new gears grinding through the residual grit as he buried the blade. By October, the operation reached its peak systemic scale. 65 bulldozers were pulling out 20,000 logs every 24 hours, feeding the logging trucks lined up along the lower Toutle River corridor. Olson didn't care about the corporate metrics. He cared about the 34-gallon-per-hour fuel burn on his machine. At full throttle, that D342T diesel engine was consuming raw capital to keep the local mills alive. The numbers were staggering, but the alternative was a total industrial shutdown. By late October, the first freezing frost hit the logging camp at dusk. The volcanic mud transformed into a jagged, frozen sheet that tore aggressively at the 24-inch extreme service track shoes. The ground conditions had changed from a shifting powder into a solid grindstone. Let me address you directly here, because if you've never tried to steer a 77,000-pound bulldozer on frozen, glass-loaded mud, you can't appreciate what Olson's left arm was enduring. Every minor correction sent a violent mechanical shockwave straight through the manual control linkages. This was brutal, exhausting muscle work. The link height on Unit 8342 was now down to less than 2 inches. The pin and bushing wear had officially reached 100%, yet the salvage operation could not halt for a standard shop teardown. They ran them until the steel literally separated from the pin joints. Destructive as it was, the fleet surpassed the 40 million cubic feet mark by November 1st. The D8Ks ground their own undercarriages into scrap metal to meet the mill schedule. No manager talked about equipment depreciation. The only metric that mattered was production and result. Olson's machine was now burning a quart of high-grade oil every 4 hours through the compromised turbocharger seals. He kept a case of premium lubricant strapped directly to the cab sweeps, topping off the hot engine block right in the middle of his shift. The D342T never stopped turning. A sudden subterranean tremor shifted a massive 60-foot embankment along the primary logging haul road without warning. Olson dropped his semi-U blade instantly, utilizing the full 300 flywheel horsepower to stabilize the dangerous grade before the loaded haul trucks arrived. The mountain was still fighting back. Raymond Davis's 50-hour undercarriage failure prediction had been thoroughly shattered by the field crew's raw, stubborn persistence. Unit 8342 had just logged its 400th consecutive operational hour in the abrasive volcanic debris. The machine technically dying, but it refused to quit. The suffocating gray wasteland was slowly giving way to clear mountain soil as the final blocks of salvageable timber were pushed down to the landing. Olson could finally see the true, devastating mechanical toll written across the scarred steel face of his bulldozer. The iron had paid the price for every log saved. If this story meant something to you, maybe buy me a coffee while I build the next one. Hit the thanks button below. It's a small gesture, but it tells me this reached you. Let's continue with Ken Olson's final stand. The massive operation had cleared over 3,000 acres of hazardous volcanic debris in less than 3 months. 65 individual Caterpillar D8Ks had completely rewritten the rules of industrial salvage operations under extreme conditions. They didn't just survive the blast zone, they tamed it. As November drew to a close, the frantic logging operations slowed down. The 65 D8K units were systematically pulled back to the main staging yard. Their steel components were completely white with baked-on silica dust. Head mechanic Ed Vance began inspecting the returned fleet under utility lights. Every single machine showed severe seal failure on the lower rollers. The abrasive dust had turned premium gear oil into a black cutting paste. Undercarriage exhaustion wear costs were unprecedented, requiring thousands in replacement parts for 65 systems. Yet, the saved timber valued out at millions. Was there any other logical choice besides this trade-off? Unit 8342 was the last bulldozer to climb onto a lowboy trailer. The D342T engine idled smoothly despite losing a quart of oil every few hours. Ken Olson unbuckled his respirator for the final time. At the dealer facility in Portland, mechanics split the worn track chains. The internal pins were completely flat on one side from continuous abrasive friction. The iron had run past its mechanical limit. The final salvage ledger recorded over 1.48 billion cubic feet of salvaged old-growth timber. The 65 D8Ks moved more material in 3 months than standard logging crews could move in 2 full years. This project fundamentally changed how heavy contractors tracked undercarriage wear life. The extreme conditions at Mount St Helens proved manufacturer maintenance schedules mean nothing in a real crisis. The field reality always dictates the limits, and they witnessed it firsthand once again. Ken Olson refused to credit luck for the historic project completion. He praised the heavy D342T block and the rugged planetary final drives. The iron did exactly what it was engineered to do under pressure. He knew the math and took the risk. Several severely battered D8Ks never returned to active forestry service. Their frames were permanently twisted from pushing giant tangled roots down steep volcanic ravines. They were stripped for salvageable parts. Unit 8342 received a full chassis rebuild and new track links. This resilient bulldozer went right back to work, clearing logging roads in western Oregon. True iron never stays idle for long. The massive earth-retaining structures along the Toutle River still stand today. They remain as a silent monument to the heavy steel fleet that shaped the landscape. They held the mud back when nothing else could. The operators who ran through the gray hell never asked for credit or recognition. They simply clock in, grab the steering levers, and change the face of the earth. The iron was just their tool. Before we close out this chapter, let me leave you with one specific question. If your final drives are groaning with abrasive grit, do you back off the throttle, or do you keep pushing until the steel breaks? Ken Olson retired in 1989. The Caterpillar D8K ran on the St Helens Salvage was sold to an Oregon contractor in 1981. The hours are estimated from service records at 12,000. The grade still stands. These machines do not ask for recognition. Neither do the operators who run them. They just push. If this is the kind of heavy equipment content you want to keep watching, subscribe to the channel. More machines, more jobs, more operators who actually knew what they were doing. And if you ran iron like this, or worked on it, sold it, bought it at auction, or inherited it from someone who did, tell us in the comments. What machine? What job? How many hours? What would you do differently with what you know now? We want to hear from you.